I'm going to talk to you about water testing and interpretation, because water quality is important, right? And you talked about water quantity. Quality sometimes as important as quantity. Well, why do we need to test our water? There are different purposes for using water. Not all the waters are created the same quality. That's why we need to find it out. If the water is used for drinking, for private owners, homeowners, the government does not have a program to mandate tests. But for municipalities, if the water supplies more than, 17, 18 people or above, there is required testing. But for homeowners, there's no requirement. So as a matter of fact, almost half of the well water or groundwater for drinking does not meet the drinking water standard. They either miss one factor or many factors. So it's important to have the water tested before used for drinking or other purposes. Now we know half of the water in the state is used for irrigation or livestock. Well, the crops has a certain requirement for water quality. Livestock also. Among the livestock, you have dairy cows, beef cows, sheep, or even chicken. Each category has different requirement for water quality. Even when we mix chemical with water to control weeds or insects, water quality is important. Actually, Dr. Angela Poston and I probably will develop a fact sheet how to use the right water to mix like 2,4-D or Roundup. The pH does affect the effectiveness of these chemicals. If the pH is too high, the Roundup is not going to be as effective as when the pH is in the right range. So different purposes have different water quality requirement. I encourage people to get them tested. Okay? I think most counties are doing very well, send samples to us. We have 3 types of water tests available: livestock, irrigation, and household. Household, the reason we call it household because we're not certified by DEQ or EPA to call it a drinking water. But basically we can provide a screening tool because it's economical. $15. If you get the same item tested at DEQ or Accurate Lab, it may cost you $180, $200. They charge $17 just for one pH. We charge $15 for a whole suite of tests. But if you really want to make sure your water is good for drinking, you do need to recommend your clients go to DEQ. They have a pretty elaborate laboratory, or go to DEQ certified lab like Accurate Lab. I'm sure the Tulsa, Oklahoma County Health Department has some testing facility as well. So to get water tested there. Plus they test some items we don't test, like bacteria, E. coli. Okay, those are important to get tested. So as far as what kind of items to be tested, now for drinking water, they need to know if the water contains any bacteria or not, especially E. coli, nitrate, and other inorganic analytes and organic analyte, especially for new wells, or the wells has been abandoned for a long time, or you suspecting some contamination. During the break, I ran into my office. Glenn from Washita County was on the phone. He said one of his homeowners tested water. Chloride is over 1,000. Total dissolved salts over 4,000. It was a good well water last year, but they applied drilling mud earlier this year. So they suspect the water might be contaminated. That's another reason they check on the water. Right now, they're not using the water. They bring water from elsewhere. for drinking. So that's the purpose to get it tested. There are some other basic tests also need to be think about, especially for irrigation and livestock. Like the total dissolved solids. Basically, we analyze the common cations and anions. EC is another parameter we test. EC is directly related to the concentration of all these dissolved ions. Because the pure water does not conduct electricity, but when you have a lot of salts there, they move electrons, conduct electricity. So it's proportional to the concentration of these dissolved salts. Actually, this is a conversion we use. From TDS, parts per million, you can convert it to EC or vice versa. Okay. So for irrigation water, we not only need to know the total amount of salts, we also need to know what kind of salts. For example, sodium is a nasty cation. We don't want it to be in our water and the soil because it absorbs a lot of water molecule and then keeps the clay particles dispersed. So deteriorates physical condition of the soil. Why clay does not penetrate water very well? Because some of this sodium keeps them apart. But if you have lots of calcium there, calcium functions just opposite to sodium. They flocculate the clay, improve the structure. That's why sometimes we recommend add gypsum to replace the sodium with calcium to improve the infiltration or improve soil physical conditions. Okay. So on the report, those two terminology you need to be familiar. Sodium adsorption ratio, it's a relative amount of sodium versus calcium and magnesium. Sometimes you see exchangeable sodium percentage. That's just another expression of the amount of sodium in the soil. Well, water sampling is as important as the lab procedure. Just like we do soil testing, we have to get representative samples. So we need to figure out how to do it. If it's for drinking water, you send to a private lab or DEQ lab. Probably you need to recommend your clientele to contact this lab ahead of time. Each lab has different requirement. Like DEQ or private lab can send the sampling kits to you, or some county health department have these sampling bottles or containers there. I don't know about the extension office. Some extension office used to have these bottles. But anyway, for routine test, the way to collect good sample is like a tap. You need to let it run for a few minutes before you collect sample. First of all, you need to rinse the container with the water to be tested several times. Normally, I just collect a little bit, let it run for a minute or two, collect some more, and let it run maybe another minute or two just to fill it up. You don't want to just turn your tap on and collect it, because the water sitting in the pipe for overnight, it may contain a little bit more metals and other chemicals. So that's how to get it representative. If it's for E. coli test, they have a tablet in the bottle to get rid of the chlorine. So basically, need to use a special bottle for that purpose. And then you also need to send the sample to the lab in a timely fashion. I think it's 36 hours. This is why we didn't want to get involved in this. If we do that, you guys have to send the sample to us very quickly, or we have to get them tested very quickly too. So that's create some issues. But there are private lab or government labs available. We don't have to get into that, I think. Anyway, interpretation is important. Now we talked a little bit over there. This is a very brief interpretation. We put some information there, like for livestock, just certain things, not over this. But there's more information out there. For example, like total dissolved solids, we say less than 3,000 ppm. That's for all the animals. But for beef cattle, they can consume water with 6,000. That's okay. So that's why we have a new program. You can using that. I don't know if you guys go into the website. We made it available. You can click this, change it to different type of water, like irrigation or household, to get different interpretation. This is something just got available in the last couple of years. In the past, you have to call the lab to change the test. And some of the items may be not there, but now it's all there, I think. Like a total soluble salts. It depends on what type of animal, how their ages. There's different criteria. So it's hard to put all this information on that single report. That's why we need to find better ways to do it. Nitrate is another issue. I mean, most of cattle probably is okay when the nitrate is over 40 ppm, but for chicken or others, they probably cannot handle with high nitrate. So different species, different age of the animal makes a big difference as well. As far as irrigation water is concerned, we want to know the total salinity and the sodium, because we don't want to get sodium into the soil. So we're using those two criteria to classify irrigation water into excellent, good, fair, poor, very poor. We have a fact sheet 2409, I think. Like a fair for this water, basically can be used on well-drained soil, and maybe need using gypsum if they continue using this water. So those interpretations are in the fact sheet. But the report does not give you all the information. Besides total salts, sodium, some individual elements like boron could be an issue. For example, some plants are very sensitive, like grape, does not handle boron very well. I think in Lincoln County, for some reason, the water, soil are both high in boron. So you have to pay attention to that. But most crops, when the boron is less than 4 ppm, probably is fine. But some specialty, especially vegetables, are very sensitive to boron. The other, like chloride, like the guy has a chloride of 1,000 ppm. It cannot be directly used for irrigation. That would burn the plants as well. So water test will provide inside information whether this water is suitable for different purposes. So for drinking water, you have different interpretations. Although we don't do microorganism or E. coli tests, but those are just information you may need to have. Like if there is a coliform bacteria, that means the water may be contaminated. Like if we have a flood, the flooding water gets into the well, get contaminated. If it's E. coli, this may be contaminated by human or animal waste. So then you may check to see if the feedlot runoff gets in the well, or is the well close to septic system get contaminated. Like nitrate for human is 10 parts per million nitrogen. If it's over that, we cannot use it. Chloride, 250. So it seems lots of information you have to remember. It's hard to keep track of them, right? If the E. coli is found in the water, you have to recommend your clients to disinfect the well. There's a lot of information available how to do the chlorination shock treatment. So I'm not going to talk about it. You can find some videotape on the website. It's very detailed, very easy to follow. So another important water parameter is water hardness, because people are using water softener. So it's based on the hardness. And most of this commercial people, they don't use in parts per million. They're using grains. So I used to get a lot of calls how to convert that. Now this is on your report. We report both hardness in parts per million and grains. Basically, it's converted by dividing this by 17. Okay? So there's a lot of information you have to remember. That's why I put all the water-related fact sheets. I need to search in other departments, maybe link it here on our website. Okay? So you can look at some of this for irrigation, this one right here. We probably need one for horticultural crops or vegetables. But recently, we have a new water test interpretation program. So if you go to soiltesting.okstate.edu, on the left side, water test interpretation, you get this page. You just click this button right here. This will take you to the interpretation program developed by Colorado State in the mountain states. They spend a lot of time and effort to develop this program. So our information is integrated in that program. You just go ahead, choose the state of Oklahoma, and then find the different type of water you want to get interpretation from, like livestock. And then just simply enter some of the analyze. From our report, if the test results showing okay, you don't even need to check on that. Just the ones questionable, like too high. You want more information, just you can enter one or as many as you want. There's a lot of things you can enter here, but you don't have to enter all of them. And then on the bottom, just click submit. For example, we enter the EC 4300, nitrate 75, sulfate 1250, and TDS 3600. This is what you get. Interpretation, like a pH, is okay. Sulfate is not. Okay. Several years ago, I think in Grady County, some producer lost several cattle. Then they found out it was due to the water sulfate too high. That time we did not offer sulfur test. So we were kind of criticize that, but we added sulfur to our livestock immediately. So you have that information now. 1,000 is the critical point. This one is over that. It tells you why sulfur is too high. If you need more information, you can read the fact sheets here. So you can save this page and then attach with the report sent to your producer. And they can read this, or they can just get more information. So this program is very powerful. If you enter the information, try to get drinking water interpretation, you can do that too. Just select that drinking water, and then enter whatever analytes you have, like nitrate, nitrogen, and fecal coliforms. Okay, this is the interpretation. The EPA limit is 10 parts per million nitrate, nitrogen. This one is 13. It's too high, so it's objectional. Here tells you why this is too high, and then more information is available linked to this page. So it's the same thing for coliforms. You don't want any coliform in the water. This is a qualitative test, present or not. But if you have it there, it's not good. It tells you why. I don't know if there's information about using chlorine to shock the well or not, but maybe you can find it somewhere on this program. So this program, it has a long list of items you can enter there. Not just the ones we test, but other tests we don't offer. like drinking water standards, everybody follow EPA, the national EPA guidelines. So the state actually does not change very much over that. So every state using the same interpretation. So I hope you try it out and then see what you think, okay? Basically, I just want you to be aware water testing is important. Continue, just encourage your clientele, homeowners, to get them tested for different purposes. Okay. We offer certain tests, but drinking water still need to go to EPA, DEQ, or EPA certified labs. This is a website. You can get additional interpretation. Okay, so I don't know. Do you have time just to go into there to check it out? Okay, so this is a SWAFR homepage. You go to water test interpretation page, and then click to the bottom here. This bring up this program. This computer is slower than mine. Okay, here it comes. So you choose a state. So those are the states already included. And then let's say irrigation. So you can enter lots of information from here to here, 2 columns. But let's try TDS. 4,500. So the interpretation come up right away. So this is too high. It tells you why. Total dissolved solids is basically the amount of okay. But this is a limit for most crops, or all the crops. But some other crops can tolerate it, like Bermuda grass. I mean, even you have 4,500, it's not a problem. They can handle it. So that's why it's hard to put all the information on our report. But this can be a good supplementary interpretation to our reports. So that's what I like to tell you this morning.